Hi, this is the first of two programs that take a look at functional groups. Functional groups are that part of a molecule that determines both its chemical and its physical properties. The functional group also determines the class of chemical. And let's look at what that means. So here I have a carbon-carbon double bond. That is, functional group is given a particular name. We call it the alkenyl functional group, and they belong to a class of chemicals that are called alkenes. Here's an example of an alkene, and I'm providing here the full structural formula, and you can see it there, the double bond. Let's look at its condensed structural formula. So CH3, CH, CH, CH3. I can recognize in here that these carbons are not saturated or full. That must mean there's a double bond present in order for the carbons to have the four required bonds. Another skill we need to do is be able to recognize from a name the functional group in the class. This particular chemical is called but-2-ene. That suffix gives it away. That is my key for recognizing that this is an alkene and contains an alkenyl functional group. The next one contains a triple bond. Triple bonds, the functional group is given the name the alkynyl functional group, and the class of chemicals are called the alkynes. This particular condensed formula would be CH3, CC, CH3. And here again I can recognize that the carbons are unsaturated, severely lacking in their number of bonds. Hence there must be 3 bonds between those two carbons. This particular chemical would be called but-2-ine. And there's the key to recognizing that it's got the alkenyl functional group. Moving on down, we have the hydroxyl functional group. And this is characteristics of a class of chemicals that are called alcohols. Here we can see that OH combination at the end of the molecule. Now this particular one, if we look at its condensed formula, CH3, CH2, CH2, and then CH2OH. It's that OH combination that gives it away. And in terms of naming this particular molecule, this would be called butan 1-ol, OL on the end. So that's a way of recognizing it's a member of the alcohols. Another containing oxygen is this particular functional group, where we notice that oxygen is sort of inserted in the middle of a carbon chain. This particular functional group is called alkoxy. And it is characteristic of the class of chemicals that are called ethers. Writing its condensed formula, CH3, then my oxygen, CH2, CH2, CH3. And as far as naming this particular chemical, this would be called 1-methoxypropane. And what gives this away is that oxy. Moving down to carbon double bonded to oxygen. This is called a carbonyl functional group. Now, this carbonyl functional group can be located either at the end of a molecule, in which case it's a member of the aldehydes, or it can be located in the middle of the chain, in which case it's a member of the ketones. So again, here we have it at the end, and here we have it in sort of the middle of the chain. The condensed formula for this one would be CH3, CH2, CH2, now C. So we don't confuse it with the alcohols and write OH. We write it as HO. That's our way of recognizing it. So again, we write it as HO as opposed to OH, so we don't mix it up with the alcohols. And in terms of naming this particular molecule, we would call this one butanal. The Al on the end indicating it's an aldehyde. This one in the middle, we would call this 2-butanone. And the "one" on the end matches with ketone. As far as a condensed structure, we would write it as CH3, CO, CH2, CH3. So this CO combination in the middle of a condensed formula is my key to recognizing it. Moving up to my last functional group, this is called a carboxyl group. And again, it can be located at the end, or it can be located in the middle. When it's located on the end, I created a class of chemicals that are called the carboxylic acids. This one would be written this way: CH3, CH2, CH2, and then COOH. That's what I look for. And in terms of naming this particular molecule, I would call this one butanoic acid. So what I'm looking for in a name is this oic acid as the key. And lastly, in the ones I'll cover in this first program, here we have it at the end, here we have it in the middle of the chain. This is an example of what we call an ester. So writing this one down, I would go CH3, COO, CH2, CH3. So that's what I'm looking for, that COO combination in the middle of the chain as opposed to the end. And naming this particular molecule, it would be called ethyl ethanoate. So what I'm looking for is this anoate at the end is my key to understanding that it's an ester. Let's look at a couple of questions then on the ideas we've covered so far. So first off, let's take a look at this one. Which contains the alkoxy functional group? That one, remember, is the oxygen connected in the middle of a chain to some sort of chain of carbon atoms on one side or the other. And it's a member of what we call the ether class of chemicals. So the key is that it's in the middle. And this one has the oxygen at the end. And this one has the oxygen, in fact, the double bonded oxygen, at the end. So that takes these two out of play. The one that fits the bill is C. If I look at it structurally, so that would have CH3, CH2, and then I'm connected to an oxygen, and then to another CH3. So right there is the alkoxy functional group, and this is a member of the ether family or ether class. Which statement is true about hexane 2-one, finishing with "one" on the end? I can remember that. That must be a ketone. So I see the word ketone here and here, but we have to remember that ketone defines the class of a chemical, not the functional group. The functional group would be the carbonyl functional group. So as a result, I'm going to go with B. In our next group, we'll take a look at 4 more functional groups. Thanks for watching.